All right, ladies and gents, welcome back to Lectures with Liddington. This episode, we are going to talk about acids and bases. So, okay, cool, acids and bases. Well, how do I know when something's an acid or when something is a base? The way that I know, the way that I measure that is using the pH scale. And what the pH scale is a measure of how many hydrogen ions are present in a solution. Remember we talked about solutions being mixtures of something dissolved into a solvent. In this case, normally water. Water's pretty common because it is that universal solvent. But pH is a measure of how many of those ions are dissolved in that solution. We would write hydrogen ions as H+. So whenever we write that H+, we know we're talking about a hydrogen ion. So acids are going to be those solutions that have a really high concentration of hydrogen ions. Remember, H+ is a hydrogen ion. So they have a really high concentration of hydrogen ions, but they're going to have lower numbers on the pH scale. So if we look over here, everything that's below a 7 on the pH scale would be acidic. So technically, milk is acidic. Cabbage, especially if you get like sauerkraut or something like that, that's already preserved, that's going to be acidic. It's a 5-ish, so it's not crazy acidic. But it is, a higher concentration of hydrogen ions than, say, water would be. And notice our friend water is right here in the middle. So acids are on that end. They are on the low end of pH scale, but that means they have a high concentration of those hydrogen ions. On the other end of this scale, my bases have a low concentration of hydrogen ions, but a high concentration of hydroxide. These are hydroxide here. Those are hydroxide ions, or the OH negative. So these would be anything on the other side here from above a 7 would be a base. We would call it basic. If we're using it to describe the solution, a solution is basic if it is a base. Milk of magnesia is an example. Lye is a very caustic cleaning agent. Another example of a base that you might have in your household is bleach. So that's another basic solution. One common misconception, sometimes you see, like the alien movies, and the aliens, they have the acidy spit, right? And they spit it out and then it burns. Well, a lot of people have that conception that only acids can burn, and that's false. Bases can do the same thing. So anything that's very acidic, so if it's really far to the acid end or if it's really far on the basic end, either one of those things can be very harmful. So not just acids can burn, bases can too. So anytime you have an item with a really extreme pH, either really high or really low, that's going to be a problem. So what does that look like when we talk about these ions in solution? This is a good illustration. Here we have a neutral solution, like water, for example. Notice we have an even amount of those hydrogen ions and those hydroxide ions. That would be a 7 on the pH scale. If we go over here to our jar with the acid solution, we've got lots more of those hydrogen ions than those hydroxide ions. So that would be acidic. Say, I don't know, a 4. I'm just making up numbers. If I go over here to my beaker with the basic solution, notice it's the other way around. I have way more of those hydroxide ions. It's very low in hydrogen ions. So I mentioned how it can be a problem if I have very acidic or very basic solutions. How we can handle that, or how living things can handle that, is through buffers. And what buffers do is they are very weak acids or bases, depending. So they're really close to that neutral area, but they're still an acid or a base. And what they will do is they will react with the really, really strong acids, really, really strong bases, in order to prevent a steep or sudden change in pH. This is really important. Buffers here are really important for maintaining homeostasis. Living things need that stable internal environment, and a stable internal pH is one of those things that they're going to need to maintain. So they do that with buffers. So next up, we're going to take a look at an example of how living things can use buffers in order to help them maintain homeostasis.